All right, thank you. So, guys, show some hands. Who of you knows Spock? All right, cool. And now, show hands again. Who of you already used Spock? OK, awesome. Still room to improve, but awesome. Have you ever asked yourself the question what it is like to work on a product that will be used by millions of people, not because they have to, but rather because they actually want to? Yes? No? Well, to be honest, I never did. Still, I got the chance to be part of exactly that. Back in 2011, when I joined Finally, the company behind Spock, I had no idea what was ahead of me. Back then, I was hired to work on a social product recommendation platform. And even though the product didn't survive until today, it still allowed us, and back then we were less than 10 people, to learn a lot of important lessons that allowed us to make Spock the success it is today. Spock itself started out as a side project at the end of the summer 2012. It took us around 3 weeks to build a first working prototype, already including the first versions of all the major components that are still there today. The apps, both Android and iOS, the media delivery service, and of course, the Discover Screen service. All that was ready just in time to present it to our investors and convince them that Spock will be the next generation classifieds market. I'm gladly thinking back to those days and nights that we spent building something completely new and great without having significant experience in the field of mobile development. Since the very first day, the most essential part of Spock has been the Discover Screen. For those of you who are not familiar with it, it looks like this. And it allows you to browse through products or items, as we call them, around you. So the challenge we had to tackle back then was to deliver records sorted by distance relative to your current location. A problem that nowadays, in the times of the IoT, has to be solved by a vast variety of services. But back in 2012, the situation was quite different. It has always been one of our, or let's say it has always been our mentality at Spock to try out new things and to not stick with technologies that have been used for years at least, simply because it was done like that forever. This was one of the reasons why we decided to choose MongoDB, back then in version 2.2, as our main database for the project. Back then, the database was pretty new to us, but we learned to tame the beast, and we managed to make it work for us perfectly. Believe me. Another principle we tried to follow was KISS. Keep it simple and stupid. So naturally, when we were facing the challenge of location-based search, we first started doing it in MongoDB. Similar to how people usually tend to do like queries in MySQL, instead of using a tool that would be better suited for the task. But to be honest, it was the right choice for the time, because it allowed us to use a tool we've started to get pretty familiar with for the task without having to dig too deep or even introduce a new tool at that point, and therefore allowed us to meet our deadline, something that we learned is critical when building something great. Not everything has to be perfect. What counts is that you make the right decisions in time and get the stuff working. You can always fix things afterwards. But being ahead is definitely the easier position than having to get ahead of your competition. So the first prototype was out. Our investors were convinced, and we started to grow. Within the first 4 weeks, we reached 10,000 downloads. And just 11 months later, already 1 million people in Austria and Germany joined the mobile second-hand revolution. As you probably remember, we were using MongoDB to deliver our records sorted by distance. This was working very well. But of course, it was just a very basic version. Back then, it was not even possible to do a simple search. So how should we tackle this new challenge? Text search in MongoDB? Well, it was possible, but to be honest, it was not really a production-ready feature at this point. And most importantly, it was not possible to both utilize a text and a geo-index at the same time. To be honest, we probably could have done it without indexes at all at the time, but of course we knew that this was not the solution to go for. So we had to look for alternatives. Back then, possibilities were still limited, but after some research, we decided to go for Apache Solr. At that stage, MongoDB has been a tool that we've already been quite familiar with. Don't get me wrong, we were far from being experts, but we knew how to run it, and honestly, we loved it. Yeah? At around that time, we not just started playing around with Apache Solr, but we also realized that our data size in MongoDB started to outgrow our capacities. So we also had to look into how to scale MongoDB vertically and what are actually the implications of that. Pretty new territory for us. And as it turns out, this way we were sorting records in MongoDB was not possible anymore in a clustered setup. So we were actually forced to migrate to a different solution before being able to upgrade our database to a sharded cluster. After playing around a bit more with Apache Solr, we finally got to a setup that we felt comfortable with to run in production. It was the year 2013 when we started to index part of our item data into Solr. At that stage, really just the essential data. Title and description for the full text search, a location for sorting, and of course, an ID to match it with the records in MongoDB. From that moment on, each and every request to fetch items for the Discover screen was first sent to Solr to get the IDs of the matching documents in the correct order, and afterwards to MongoDB to fetch all the other necessary data. So, with Apache Solr in place, we once again reached another milestone. And we were able to focus again on new features and improvements of the user experience. But of course, if your service is growing like hell, you're constantly hitting new limitations. Not just product-wise, also team-wise. Yeah? In the past 5 years, our team size multiplied several times. In summer 2014, we were just 20 people. Today, there are 130 hungry, success-driven team members from 30 different nations, part of the Spock team. And we are still growing. Also, space-wise, the office you can currently see in our cool video on the jobs page next to our more than 20 job ads is actually my personal 5th since I joined the company. And it's already getting cozy again. Product-wise, one of the limitations we reached was that we were pretty soon lacking read capacity on Solr. To resolve this, we went for the obvious choice and started adding more replicas to it. This solution gave us some room to breathe and some time to think about other optimizations to be able to keep up with the growth. I distinctly remember when we were once again sitting together, putting our heads together, trying to find yet another optimization. It has already been quite a long day when we came up with the idea to simply limit our candidate set to a circle around the location of the user. At that time, the majority of our users has been in urban areas, and there the density of items, was quite high. In our minds, filtering out the documents outside of a circle around the location of the user should significantly improve query time and therefore free up resources for other and more queries. And we were right. The change was so simple. Just apply the filter, and if no more items were found, remove it. Not detectable by users at all, and still very effective. In the end, the vast majority of all queries were able to be delivered with this filter applied. So we once again improved performance, and we were able to focus on other challenges. Shortly after introducing the circular filter, we realized that a box-shaped filter is actually way less computationally expensive, while still delivering almost the same results. At least the performance gain definitely outweighed the loss of precision. With this setup in place, we were pretty certain that nothing could ever get in our way. Wrong. Wrong, of course. I mean, as it is with most of those tools out there, running them for development purposes, running them in a small to medium-sized production environment is fairly easy. You just download it, you adjust minor configuration options, you start it, and you are covered in most of the cases. But once you reach a certain scale, all those nice default configuration options suddenly stop working for you. And you find yourself on a Sunday night trying to tune a tool you realize you have actually no clue about. And as if this wouldn't be bad enough during a normal workday, having to do this on a Sunday night, the most busiest time for Spock users, and knowing that all of your users basically have to suffer from a bad performance really is the tip of the iceberg. During those nightly sessions, we realized that we reached a point where we needed help from someone who knows how to run Solr and who knows how to tune the Java VM. As it turns out, finding such a person is far from easy, believe me. After days of asking around, of doing calls, and I don't know what else we tried, we finally found somebody who was able to give us some help. Who of you is familiar with that? All right. This is the memory graph of one of our Solr servers, and I can tell you, it's not looking good. But with the help we got, we were actually able to monitor this and other important metrics of the JVM, and we tried to tune it to an extent that allowed us to continue to deliver our service. Still, it was clear to us that this is not a permanent solution. Without having somebody who knows how to run Solr, who knows how to tune the JVM, we were actually left with only one option. We had to replace Solr with something we were more comfortable with. A bit earlier this year, we started to introduce Elasticsearch and use it for our newsstream feature. And we were therefore able to gain insights in how to run it. After realizing that we are not going to become BFFs with Solr and getting a bit more insights and playing around with Elasticsearch, we decided to give it a try. Even though our search in Solr was not able to compete with the precision and the comfort provided by Google, we still didn't want to accept a major change there. So we were once again tackling a tough problem. Tuning Elasticsearch to deliver the same search results as Solr provided for the same query. One would think that this is actually a quite easy task, since both tools under the hood utilize Apache Lucene to do the heavy lifting. But I can tell you, it was very difficult to make the search in Elasticsearch behave similar to Solr. It actually was a very long and tedious task. And still, Solr was not able to keep up with the huge growth phase we've been in. So we decided to go for an intermediate solution. Even though search was behaving differently in Solr and in Elasticsearch, applying filters was working exactly the same. The only filters we had available in 2014 was categories, filters for items that were newly listed, filters for items from your friends. And the intermediate solution now was to offload Solr from those filter-only queries and send them to Elasticsearch instead. The benchmarks we did beforehand already showed us that Elasticsearch does not only come with a pretty good default configuration, but also that its response time is crazy fast compared to Solr. And this was the case even though we started to index all the data that was required to deliver requests for the Discover screen in Elasticsearch. If you remember, in Solr, we only stored a small subset that was required to do queries, filters, and sorting. Gradually moving over filter queries from Solr to Elasticsearch was one of my personal highlights in the Spock history. And having a significant part of the load offloaded to Elasticsearch, of course, freed up resources in Solr and therefore allowed us to continue tuning the search to match the results in Solr without being pressured by a bad performance of it. Finally, after a couple of more weeks of tuning, we were satisfied with the results and we decided to give it a try in production. So we started to send a small portion of the search requests to our back then small Elasticsearch cluster. And the results? They were amazing. Yeah? Not only was Elasticsearch delivering the same results, it was way faster in doing it as well. I can still remember the day when we then finally fully switched to Elasticsearch. It was the day of our legendary Christmas party in 2014. And it was around 30 minutes before the start of the party. We have already gathered, we were sitting together, we were talking, we were joking around, and we were joking about giving ourselves the stopping of Solr as a Christmas present. And those jokes, they actually turned into actions. Shortly before the start of the party, we did the switch. It felt so awesome to finally not rely on Solr anymore. It felt so awesome that we had to party all night long until it was getting light again, because this was such a great Christmas present. Even though the switch to Elasticsearch already gave us a major performance boost, we didn't stop there. Since then, we improved the performance with a lot of small but smart tricks. And I'm really proud that I can tell you today that we can deliver requests to Elasticsearch in average in less than 20 milliseconds, considering the fact that our result sets are sorted by distance and not relevance, and the fact that our candidate set covers millions of records. All right. So, to summarize our learnings. First, fail. Fail, but learn from it. Don't just give up. Next, never never be scared to try out new things. Give them a chance, and then decide for yourself. Be smart, but be fast. This is really essential. And last but not least, don't be scared to get help. I know this is especially hard for a developer, for engineers, but in the end, it is really essential to realize when you are stuck and get help there. Working on Spock really is an awesome experience, and I'm gladly looking forward to the challenges that are still ahead of us. But honestly, all that would not have been possible without the awesome team behind our app. Thank you.
Thanks, Klaus, for this very interesting talk. Now we again have a Q&A session, and I will ask the first from the app. So basically the question is about, did you consider losing Solar Cloud before switching to Elasticsearch?
Honestly, we had a look into that back then, but we were already a bit steered toward Elasticsearch. Yeah? I mean, Solar was, I have to be honest, it was pissing us off a bit. Yeah? And we had Elasticsearch in place, so we were simply able to play around with it, and therefore we were not really considering Solar Cloud. Yeah.
Perfect. Are there any other questions? Please raise your hand if you have questions. One here. Please wait for the mic. Is the... Okay, no mic.
You said MongoDB clustered mode, right?
Yes.
The query was broken. Why?
Yeah, that was a restriction back in MongoDB 2.2, 2.4. Not sure which version we were exactly running back then, but it was not possible anymore. Yeah? So the geo functionalities in MongoDB improved significantly in 2.6, as far as I remember, but back then it was simply not possible.
More questions here?
Can you talk about the size of your Elastic installation, like how many nodes, shard replicas you have running?
Sure. So overall, we have currently 3 clusters for different purposes. The one I'm talking about is a cluster with roughly 80 nodes, but not just running an index for item search, also other things. Item index itself is somewhere around 20 shards, I guess. And a couple of replicas, of course, for high availability.
Any more questions? Just raise hand here, in the left side of the room. Please wait for the mic.
Mic, yeah.
Few seconds.
1, 2. At what point did you find your CTO?
CTO? We actually don't have a dedicated CTO. Yeah? We are a bit more liberal there, and we are sharing basically the responsibility of a CTO between myself, Nem, who is in the back, and a colleague of mine who is not here today.
Any more questions? No. Then I would say I introduce. Sorry for this.
Okay. Hi, thank you for your talk. My question would be, did you ever face shard corruption or index corruption with your Elasticsearch cluster?
Not on this index, thankfully, because we are very careful with it. But we've seen it with other installations of Elasticsearch, especially our logging stack is facing this because it's insanely huge and a lot is going on. Yeah.
And in this case, when index corruption happens, do you just, if it's your logging stack, just throw it away and set up a new one, or do you actually have a strategy to repair the cluster?
It actually depends. Yeah, I mean the logging cluster is usually not the most critical part. Yeah? And I've never seen a whole index to be corrupted, so it was just shards on it. And in this case, we usually just discard this one shard, and everything else is working fine. But there was already also an incident where we were able to recover the data from a corrupted shard. Yeah? I have to look up our documentation, how we did it. I don't know it from the top of my head, sorry.
Okay, do you, by any chance, have a blog post in the pipeline to just fix that?
It's not planned, but it's a good point. If I get to it, I can definitely try to do this, yes.
Thank you very much.
Welcome.
That was the Q&A, I guess.
There is
no
another
more
question.
questions. Here again, okay.
Thank you. You didn't mention about MongoDB. Did you throw it away? How did you?
No.
MongoDB. Did you? Are you still like syncing them with
Yes.
Mongo connector or what?
No.
MongoSestic or?
We have a separate process. So MongoDB really is our main data store, and it will stay like that at least for the moment.
Okay.
Yeah. Elasticsearch is really just there to do what it's doing, what it's best at, and this is search for us. And we have our own process to sync data from MongoDB.
So you developed your own tool to
Yes.
synchronize it.
But since you mentioned Mongo Connector, we already also have this in use. This is really when we want to replicate the whole data exactly the same fashion it is in the original.
Okay, thanks.
Any other questions? There's one more in the middle. Yeah, one more, yeah.
I understand the app is available in more than one country. So is there only one item index, or do you have more?
Currently, we are using one, but we are thinking about splitting this whole thing up to have it more decentralized. Yeah? So to have separate indexes, maybe per country, maybe overlapping. We are not yet sure on it, because it's why we have one index is because we also want to allow users that search for items in Austria to find items in Germany. Yeah? So splitting simply by country would not work for us. But we are working on changing this. This is definitely something on the roadmap.
And how do you handle backups?
With Elasticsearch?
Yeah.
Snapshots. Yeah, so we do daily snapshots of it. So we could restore from that and just apply the changes that happened in the meantime within, I'd say, an hour. Yeah. So restoring from a crash in Elasticsearch is not really such a big deal for us.